Hello everyone, welcome back to Chinmoy's Biology channel. So with a new episode of Force and Pressure, let's get started. Now in the previous episode, what we have discussed, I hope you have already gone through that. If you have not gone through that, please go through that. I am putting the link in the description box down as well as in the I link above. So today's episode will be a very important one with different types of forces, and I will be discussing about many new things in this episode. So don't skip in the middle of the lesson and please stay tuned throughout the episode. So let's get started without further delay. So in the previous episode we have discussed about that force can change the shape of an object, force can make the stationary object move, force can change the speed of a moving object, as well as force can change the direction of a moving object. So today, with this force can change the shape of an object, we are going to discuss about a few more examples. Okay, so let us see the examples given in this activity 8.5 as per your NCERT book. So some situations have been given in column 1 of table 8.2 in which objects are not free to move, okay, and in column 2 of the table suggests all the manner in which the force can be applied on each object, while in column 3 it shows a diagram of action. So first we are showing how the force is applied and how the object is not moving freely. Now in the column 2, the type of force in which the force can be applied on each subject is shown to you, and this column 3 is showing the diagram. So it is showing the diagram of action. So try to observe the effect of force as many situations as possible, and you can find similar situations available from your environment as well. So let us take this because in the previous episode I took only one example of this making a dough. So first is a lump of a dough on a plate. You can see this diagram here, pressing it down with hands. So change in the state of motion, what is happening, yes or no, change its shape. You are supposed to think and write. So is there any change of state of motion, or is there only a change of shape? So what do you think? You just think and write, and we will clarify with the answers in the next class. Now spring fixed to the seat of a bicycle. So here spring is fixed to the seat of a bicycle. By sitting on the seat, what is happening? Can you tell that whether it is changing the motion of the seat? I don't think it's happening, but it is changing the shape of the spring. Okay, so not this object, the change of shape of spring is happening because when the pressure is applied, the spring is squeezing. Now next comes a rubber band. You can see a rubber band is being hanged or suspended from a hook fixed on a wall by hanging a weight or by pulling its free end. So what is the change of shape of the this has been happening here, this rubber band. Okay, so again you are supposed to think and answer this question. A plastic or a metal scale is placed between two bricks. So it is placed between two bricks. By putting weight at the center, what is happening? So that you need to tell, you need to think and tell that. So now you can see in this diagram that the metal scale, we can see that the metal scale, little bit change of shape has occurred here. But has the change of shape caused any change of motion? I don't think so. You just think on your own and then only you write the answers in this gaps. Okay, and we will discuss it in the next class. Now we will move on to that force on an object may change its shape. So what it can do, so may make an object move from rest, may change the speed of an object, we have discussed earlier in the previous class, may change the direction of motion of an object, and may bring about a change in the shape of an object. So these are just a quick revision we are doing. Okay, so it may also cause some of all these effects. Okay, so while a force may cause one or more of these effects, so as we have discussed about these effects in the earlier class, it is just a quick revision or recap of the previous class, and then we will start with this today's contact forces. Now it is important to remember that none of these actions can take place without the action of a force. So thus an object cannot move by itself, it cannot change speed by itself, and it cannot change the direction by itself, and its shape cannot change by itself. So this is only happening, it is only changing shape, it is only changing the direction, it is only changing its we can say from motion to rest or rest to motion. These actions are only done if force is applied. Now we will move on to the different types of forces. So in that first comes the contact force, and in that we will first discuss about the muscular force. So what is muscular force? So as we are here with contact forces, so as the name suggests, contacts means when you are coming in contact with something. So how is it related with muscular force? We should know that, right? So just think, can you push or lift a book lying on a table without touching it? Can you lift a bucket of water without holding it? No, it's not possible. You can't lift a bucket of water without holding it. So, to apply force in these cases, you have to touch the object, okay? So, your body has to come in contact with the object. So, that's why it is called contact force. The contact may also be like with the, we can say the contact will also it can be with the help of a stick or a piece of rope. It's not like that your hand should help, go and touch the object. You can also use a stick or a rope. So when we push an object or like a school bag or lift a bucket of water, where does the force come from? Where is the force coming from, right? So this force is caused by the action of muscles in our body, and the force resulting due to the action of muscles is known as muscular force. So when your muscles are coming into action, that contact force which is done by the muscle, that force is called the muscular force. Is it clear to all of you? Okay, it's very easy. Now it is the muscular force that enables us to perform all the activities involving the movement or bending of our body. Now in your previous class, you have already studied about the process of digestion of food that gets pushed through the alimentary canal. Could it be a muscular force that does it? You also know that lungs expand and contract while we inhale and while we exhale air. So where are these muscles located which make the breathing possible? Can you list a few more examples of force exerted by the muscles in our body? So you know that our body is made up of muscles, bones, and also it is a skeletal-muscular system. So how the muscles are helping each and every part or organs of our body to work, you can just make a list of things, okay? So just think like the lungs are working, like the digestive system is working, what all other systems are there where muscular force is involved. Just make a list of that in your answer book. So it's just for your curiosity, for your knowledge, and for your recalling capacity, right? So animals also make use of their muscular force to carry out the physical activities and other tasks. Animals like bullocks, horse, donkeys, and camels are used to perform various tasks for us. In performing these tasks, they use the muscular force. So now you can see the muscular force of the animals is used to carry out many different tasks. They are pulling this cart with the help of their muscular force only. Okay, is it clear to all of you? Now, since the muscular force can be applied only when it is in contact with an object, it is also called contact force. So, contact force and muscular force are interrelated to each other. So, when you are coming in contact with the object only, you can use the muscular force. So, are there other types of contact forces? Let us find out that. So, in that first comes the friction. Okay. So, recall some of your experiences. Just you think, you sit quietly and listen to me what I am telling. So, a ball rolling along the ground gradually slows down. So, you are rolling a ball along the ground. It's gradually rolling and it's slowing down, and finally it's coming to rest. How? So when we stop pedaling a bicycle, it gradually slows down and finally comes to a stop. A car or a scooter also comes to rest once its engine is switched off. Similarly, a boat comes to rest if we stop rowing it. Can you add some more such experiences? Okay, so there are many such experiences like that. when you are stopping to pedal the bicycle, it will come to rest. When you are stopping the engine of a car or a scooter, it will come to rest. Or similarly, the boat comes to rest when we stop rowing. So in all the situations, no force appears to be acting on the objects, yet their speed gradually decreases and they come to rest after some time. So how it is happening? What causes a change in their state of motion? How could some force be acting on them? Can you guess the direction in which the force must be acting in each case? So these are the questions which are coming in your mind constantly. Is there any other forces which is making them to stop? Is there anything which is changing the direction of the force? So these questions keep on coming to your mind constantly. So we will answer these questions now. So here comes the important thing. The force responsible for changing the state of motion of objects in all these examples is the force of friction. That is the frictional force. The force of friction between the surface of the ball and the ground that brings the moving ball to rest. Okay. So when the moving ball is coming to rest, it is due to the force of friction, the ground that brings the moving ball to rest. Similarly, friction between the water and the boat brings it to stop when you stop rowing. So the water and the boat is having a frictional force. When you stop rowing, the frictional force causes the boat to stop. The force of friction always acts on all the moving objects. Its direction is always opposite to the direction of the motion. So whenever you are walking also, your feet is having a frictional force with the ground. So the frictional force is acting opposite to your motion. Okay, since the force of friction arises due to contact between the surfaces, it is also an example of contact force. So details about the friction we are going to learn in the next lesson, chapter 9. So for that you need to subscribe to my channel. So whenever I am teaching your next lesson, you will get a pop-up so that you can continue learning with my videos and my lessons in a systematic way. So if you are liking my channel, please do subscribe and don't skip my lessons in between. So let's move on now. You may be wondering whether it is essential for agent applying a force or let on an object be always in contact with this. Let us find that. So till now we were discussing about the muscular forces, contact forces. Now we will move on to the non-contact forces. Okay, so where you are not directly coming in contact with the force, in that the first one is the magnetic force. Okay. So in non-contact forces, first we are taking magnetic forces. So let us see what is there in activity 8.6. Okay. So take a pair of bar magnets, place the longer side. Now you can see you have taken a pair of bar magnets and you have taken the longer side of the bar magnet, or we can say over the 3 round pencil. Okay, so longer side of the magnets over 3 round pencils or wooden rollers as shown in the figure. You can use pencil or you can use wooden rollers instead. So what is happening here? Now make sure that the 2 magnets do not touch each other. So there is a gap in between 2 magnets. They are not touching each other. And now bring the other end of the magnet near to the same end of the magnet placed on the rollers. Note what happens to the magnet placed on the rollers every time another magnet is brought near to it. So whenever you are bringing this magnet near to this magnet, so what is happening? So you are taking 2 bar magnets, you are placing another bar magnet on 3 pencils or wooden rollers, so that whenever you are placing another magnet close to that, what is happening? So is the other magnet rolling away or rolling near to you? So what is your observation? So observing attraction and repulsion between the 2 magnets. So what you are observing? First, you need to write that. So what we are observing, let us see. Now, does the magnet on the rollers begin to move when the other magnet is brought near it? Does it always move in the direction of the approaching magnet? Suppose this is the magnet which you are holding. So is it approaching towards this or is it moving away? So what is happening? Now, does it mean that some force must be acting between the 2 magnets? So there is a repulsion, there is an attraction. So repulsion means moving away from that object, and attraction means that moving towards that magnet. Okay. So you have already learned in class 6 that like poles of two magnets repel each other and unlike poles attract each other. So you know that unlike poles of magnets are attracting each other. Like north pole will attract the south pole, whereas the north pole will repel the north pole and south pole will repel the south pole. So attraction or repulsion between the objects can be seen as other form of pull or push. So do you have to bring the magnets in contact for observing the force between them? No, a magnet can exert a force on another magnet without being in contact with that. So these are non-contact forces. If two magnets are brought just nearer to each other, if it is the north pole, if it is the south pole, they will attract each other. Okay, so this is what is happening. So these are all non-contact forces. Okay, so the force exerted by the magnet on a piece of iron is also a non-contact force. Is it clear to everyone? Now we will move on to the next type of non-contact force, that is the electrostatic force. Okay, so let us move on to this. Now we are coming to electrostatic force. Now take a piece of straw and cut it into nearly 2 equal pieces. Okay. So this is activity 8.7. We are seeing here we have taken a piece of straw and we have cut it into almost two equal pieces. Suspend one of the pieces from the edge of the table with the help of a thread. So what we are doing, we are suspending one straw with the piece of a thread at the end of the table, and now we are suspending, and now hold the other piece of straw in your hand and rub its free end with a sheet of paper. So this free end you are rubbing with a sheet of paper, right? Okay, so bring the rubbed end of the straw near the suspended straw. Make sure that two pieces do not touch each other. So what do you observe? Next, rub the piece of the free end of the suspended piece of straw with a sheet of paper. Again, bring the piece of straw that was rubbed earlier with the paper near the free suspended straw. What do you observe now? Now, what you are doing, you are suspending this with a thread. You are holding this with in your hand, and you are rubbing this front part sometimes with a sheet of paper, and again you are rubbing this part with a sheet of paper. So when you are bringing this close to each other, you will see that the rubbed straw with paper attracts another straw but repels it if it has also been rubbed with a sheet of paper. So first, when you are rubbing the sheet and this sheet was unrubbed with a sheet of paper, then it was attracting this part. But when you have rubbed both the sheet, what is happening? They are repelling each other. So here also you can see that there is a change of motion, there is a change of direction of the straw without any contact force being applied. So is it clear to all of you? So a straw is said to have acquired an electrostatic charge after it has been rubbed with a sheet of paper. Such a straw is an example of a charged body. The force exerted by a charged body on another charged body or uncharged body is known as electrostatic force. Now, this force comes into play even when the bodies are not in contact with each other. Now, the electrostatic force is another example of the non-contact force. So, the first was magnetic force, second is electrostatic force, and third we will come to the gravitational forces. So, they are also non-contact forces. So what is gravitational force? You know that a coin or a pen falls into the ground when it slips off your hand. Leaves and fruits also fall to the ground when they get detached from the plant. So have you ever wondered why they are falling towards the ground, why they are not being flown away or blown away? So when the coin is held in your hand, is at rest, as soon as it is released, it begins to move downwards. It is clear that the state of motion of the coin undergoes a change when you are throwing the coin down. So can this happen without a force acting on it? So what is the force? If you are dropping the coin, if you are dropping an object, if a fruit is falling, if a flower is falling from a tree, what is the force on which it is depending to change its action, the direction of the motion and all? So The objects or things which fall towards the earth because it pulls them, this force is called the force of gravity or just gravity. This is an attractive force, and the force of gravity acts on all subjects. The force of gravity acts on all of us all the time without our being aware of it. Water begins to flow towards the ground as soon as we open the tap. So water is moving towards the ground. It is moving in the bucket itself or from the tap down. So water in rivers flow downwards due to the force of gravity. So gravity is not a property of the earth alone. In fact, every object in the universe, whether small or large, exerts a force on every other object, and this is called a gravitational force. So today we have studied about electrostatic force, magnetic force, and gravitational force. So in the next class, in the next episode, we will be dealing with the pressure part. Okay, so what we are dealing in pressure, we will study about pressure, we will study about the pressure exerted by the liquids and gases, and we will also study about the atmospheric pressure and all. So to know so many things in the next class, many interesting upcoming episodes, please stay tuned, stay updated, and subscribe to my channel, and don't forget to share it with your friends. And if you like my channel, please do write in my comment box any queries, any doubts. I'll get back to you in the next episode. So till then, stay tuned, subscribe, watch my full videos, and thanks a lot for watching my videos. Bye bye.